Okay, Assalamu alaikum, Bismillahir Rahmanir Rahim, and Assalamu alaikum. Today we are going to discuss, after a considerable break, a very important topic that is related to object-oriented programming. And this topic basically concerns the relationship between objects. So today, we will talk about the two different types of relationships that are possible between objects and that we observe to exist among real world objects. So we'll talk about these objects, we'll mention what these we'll talk about these relationships and we'll mention what these relationships are. Then we will study one type of relationship a little bit deep, and the other one we will discuss in the coming lectures. Okay, so this is the outline for today. So today we'll talk about the different types of relationships between real world objects. So we'll basically talk about two types of relationship. One is the is a relationship, and the other is the has a relationship. Now the is a relationship and the has a relationships, these are two of the most common types of relationships that you can find in real world objects. So we will see where does these relationships stem from, or where do these relationships originate from. Okay, so one, we'll talk about that, and two, we will talk about these relationships in the context of C++. So what does it mean to have or create such a relationship between C++ classes or objects, and how do we create these relationships. Okay, so we'll talk about these things. Now the is a relationship, it is basically concerned with categorization. Okay, so if we have a lot of objects, one thing that we almost always do is we try to categorize those objects based upon some common characteristics. So objects having one set of common characteristics, we categorize them into one class of objects or one type or category of objects, and objects having another set of attributes or characteristics that are common among those objects, we try to categorize them into a separate category. So you're aware of these categorizations. This is what almost always we try to do. For example, in the field of biology, like you're aware that we tend to categorize material things into living and non-living matter. Okay? So the first categorization is living matter and then non-living matter. So living objects have a certain set of characteristics. They consume food, they reproduce, they do respiration, they have some sort of excretion mechanism, and all these characteristics, we are aware of that. And then the non-living things, they have basically the absence of those characteristics make them non-living things, something like that. Then we tend to divide living things into plants and animals. Okay, and there may be some certain other categorizations as well, or maybe there are certain things that need to be categorized into their own separate categories. For example, viruses. So viruses are a very what can we say, a confusing kind of creature. So they can be categorized as living beings and they can be categorized as non-living beings, and some people categorize them into a separate category of their own. Viruses. Bacteria are simple. Bacteria are basically mostly plants. So bacteria are plants. So we have living, non-living things. Then among living things we have plants and animals. So among plants and animals we try to differentiate at the cellular level. Say for example, plants consist of are made up of cells that have a cell wall, and animal cells do not have a cell wall, they have a cell membrane. Okay, so plant cells have a cell wall as well as a cell membrane. So that is perhaps the only difference between these two. And then plants can be divided into like hundreds and thousands of different categories, and similarly animals have been divided into hundreds and thousands of different categories. So categorization is a major thing that we do in almost every subject. So say for example in chemistry you're aware of the periodic table. So in the periodic table, like we have different elements. Say we have around I don't know, the number keeps on changing, but when we were studying it, so the number used to be around 115, 112 different elements. Okay, then there are other heavier elements that are basically discovered after some time. So we tend to divide those elements into different groups, and those groups basically show similar chemical characteristics. For example, we have a group of alkali metals. So alkali metals include lithium, although the group also contains hydrogen, but hydrogen is a gas. So lithium, sodium, potassium, and then cesium, francium, I guess. I don't remember exactly, but I'm sure about lithium, sodium, and potassium. Now, all these metals, they are called alkali metals. One of their characteristics is that they are highly reactive. They have a single electron in their valence shell. Their valence number is +1, so they tend to lose that electron and form positive ions or salts. Okay, so you'll commonly find these elements in salts. Different salts, like, they will have this element. Similarly, if we look at another group of elements, the halogens. So the halogens are basically gases like fluorine, chlorine, and iodine. Iodine is not a gas, but so these gases, these elements, the halogens, they have 7 electrons in their valence shell, and that gives them similar chemical characteristics. Okay, so they are also highly reactive. They are also mostly found in salts. Okay, and you will find them react very commonly to the alkali metals. So you'll pretty much find the most widely compound that has an alkali metal, the most widely available compound that has an alkali metal and a halogen is sodium chloride. So the seawater is full of it, and there are mountains of it in Pakistan. Okay, so the point that I want to make it is that much of science, whether it is biological science or whether it is chemical science, much of science is mostly considered with categorizing objects into different categories. So much of science is involved in, and that is done basically on the basis of common characteristics. So we try to find common characteristics, and then based upon those characteristics we try to create new categories. Okay, so this is how we try to simplify the world around us. We have to deal with millions and billions of objects and organisms and all those things. In order to make their study easy and understandable, what we do is we try to categorize them, and the number of categories are definitely fewer than the number of objects themselves. Okay, so the first thing, now this type of relationship is called an is-a relationship. An is-a relationship allows us to create categories. Okay, now why do we call it as an is-a relationship? Now if you look at the categories that we talked about, so if we look at, for example, let us look at different animals. Okay, so all animals are living things. An animal is a living thing. Okay, so living thing is an animal is basically a subcategory of living things. Okay, an animal is a subcategory of living things. Another subcategory is plants. Now inside animals we have a category of very small animals, single cellular animals, unicellular animals. So that category, I hope if you remember some of your biology, so those animals are called protozoans. Okay, so they are basically categorized into the phylum Protozoa. So protozoan, and an example of that is amoeba. Okay, so amoeba is one unicellular element, and whenever you get some pain in your tummy because of the polluted water that you might have had, so most probably it is because of that amoeba. Okay, so there are medicines, say for example flagell and all that, so they can treat infection due to amoeba. So amoeba is a very common protozoan that you come across, that we come across in our daily life, especially in Pakistan. Okay, so it is found in water, and it can make way through our drinking water, through pollution or contamination or whatever. So if you drink it, it can give you infection. It can give you dysentery. Okay, so the so that is one. So an amoeba is basically an animal, and it is a living thing. So there is a relationship between amoeba and the animal class or animal category and the living things category. Okay. Similarly, we can have other different categories. For example, we have a very huge collection of animals that we call the vertebrates. Okay, so vertebrates are animals that have a vertebral column or a backbone, some sort of backbone. Okay, now in that category there are further categories as well. So we have birds that are basically vertebrates. We have mammals that are vertebrates. We have reptiles that are vertebrates that have a vertebral column. We have amphibians, okay, so that have a vertebrate. So all these categories we have, and like they have an is a relationship between among themselves. So for example, let us take a reptile, a lizard. So a lizard is a reptile, a lizard is a vertebrate, a lizard is an animal, a lizard is a living thing. Okay, so a lizard, it has an is a relationship with all the classes above itself in the hierarchy. So we'll look at it in more detail. Now the way we create these categories or classes, you should not confuse it with classes. In fact, I should be using the term categories. Okay, although they mean the same thing, but here in this course, class it has a different connotation. Class means something else, so we should be using categories, and we are basically creating categories of classes. So we are basically bunching similar classes together in one category. Okay, now when we do this, we have class hierarchies. Okay, so what is a hierarchy? So a hierarchy has many different layers. Okay, so on the top layer, say you have some category, then from that category we can derive, or we have some more specific categories, and then from that category we have some more specific categories. So we look at some class hierarchies, and after we look at that, like, you'll be clear about it, hopefully. So the class hierarchies that we look at would be from different areas. So we will look at different shapes, and we will try to categorize those shapes, and based upon those categories we will have a class hierarchy or a shape hierarchy. Okay, then we will look at different employees in an organization. For example, the organization is our university, and we will try to categorize those employees into different categories, and that will give rise to a class hierarchy for that organization. Okay, then we'll look at the animal kingdom that we just talked about, and then we'll also look into another very different situation. It does not concern any organisms or living people or employees, or it's basically a very virtual kind of concept. So when you go to a bank, you can open different types of accounts in that bank. Now those accounts, if you look at them closely, if you observe, if you look at the characteristics of those accounts that the bank offers you, they can be categorized into different categories, and that can also result in a class hierarchy. In fact, at the very end of this lecture, we will implement a very simple class hierarchy, and that will involve accounts in a bank. In order to demonstrate what inheritance, how do we implement inheritance in C++? Okay. So I guess this is the first time I mentioned the word inheritance. We have only been talking about relationship between objects, and we have mentioned only is a relationship and has a relationship. Inheritance is just another name for is a relationship. Inheritance is just another name for is a relationship. Now, what is inheritance? So I guess you are aware of it. Inheritance is like you create one class from another class. Okay, so you create one category, new category, from an existing category, and the new category that you just created, it inherits certain attributes or characteristics from the existing class or existing category. Okay, that is what inheritance is. So when we create class hierarchies, so we can think of those hierarchies as having some sort of a mechanism for inheritance, because in those class hierarchies we have classes at the top of that hierarchy from which we derive new classes, and those new classes, they inherit characteristics of the existing classes. Now this will become more clear when we actually look at different class hierarchies. We will return to this discussion there, but inheritance is just another name for is a relationship. Okay, inheritance is just another name for is a relationship. We'll talk about all the terms that are used for inheritance or is a relationship, but towards the very end of this lecture we will learn how to implement or do inheritance in C++. In programming languages, inheritance or the implementation of is a relationship or the use of is a relationship has a specific purpose, and it has a very useful purpose. Okay, so we'll talk about that, and that purpose basically is the ability to reuse existing code. So we want to, in software, perhaps software is one of those fields where we actually love to reuse existing code. Okay, and in fact, people who write code, like if I write code, I would like you to reuse my code. Okay, so I would not want you not to reuse my code. I would like you to reuse my code, and I would like you to improve it further. Okay, so this is code reuse. It saves time. If I have spent time on doing something and I have come up with something good, so I want you to save your time, and I want you to improve it further if it needs to be improved or if it can be improved. But I would not want you to reinvent the wheel and rewrite the same code that I have spent so much time on. So we'll talk about is a relationship in further detail, and that will hopefully clarify the different things that I've talked about so far. The other relationship that exists between objects is the has a relationship. Okay, has a relationship. Now has a relationship, like there are different terms that can be used to call the has a relationship to. So one is, say, association, then we have aggregation, and then we have composition. Now we will differentiate between these different types of relationships. Okay, but at the core of all these things, like the thing that we are interested in is the has a relationship. Now I'll give you an example, a couple of examples to understand what the has a relationship is. So say, for example, consider a car. Now a car is an object, a very complex object in itself. And if you look at a car is basically a composition of different objects. A car has an engine, Now pay attention to the word has an engine. Okay, a car has doors, a car has a transmission, has a transmission. So we have a car, which is an object, and that object by itself is composed of other objects. Okay, it has other objects. So it has a relationship with other objects. A car has a relationship with other objects. Okay, so a car has an engine, a car has a transmission, a car has doors, a car has seats, a car has, for example, uh, brakes. Uh, if we consider the engine, say for example, so an engine has an ignition system, an engine has a fuel injection system, an engine has a loop system, an engine has a cooling system. So now all these systems, they are complicated objects by themselves, and the engine, which is in itself a very complicated object, it is composed of all these systems. Okay, so it has a relationship with all these systems. Now in C++ we can also have this relationship between objects. We can have this relationship between objects. Say for example, if we are writing a software that is concerned with automating operations at a university or at any for any organization. So the organization would be an object, say the university would be an object, and the university would have students, it would have employees, it would have, say, departments, it would have different other objects, and those objects will have certain other objects. Okay, so they will has a relationship with other objects. So we'll talk about this has a relationship as well. In C++, if for example we have a class and one of the attributes of that class is an object of another class, so we say that there is has a relationship between those two classes. Okay, that is what it is. So basically, like up until now, we have been using the built-in types, say double and character and float and integer as the attributes of a class. Or one of the examples that I gave you, one of the questions that I gave you in the midterm exam, that required you to, I guess one of the questions that I gave you was that I asked you to declare a pointer as a member, as a data member, or as an attribute of a class. Okay, so except for that, like, we have not used any other type of variable or object as an attribute of another class. Now if one of the attributes is an object of another class, then these two classes has a relationship. So we'll talk about this as well in our future lecture. Okay, and that will be soon, inshallah. Okay, so let's start. Now look at these shapes. Okay, so if somebody asks you to organize these shapes into different categories, so you can come up with different categories. Now if you look, there are some shapes that are two-dimensional, and there are some shapes that are three-dimensional. Say for example, this is a sphere, this is a cube, this is a cylinder, and the rest of the shapes are two-dimensional. Okay, this is a rectangle, this is a square. If you look at these shapes as well, so you can categorize them. Now some of them are quadrilaterals, they have four sides. Okay, now this one is a circle, it does not have any sides as such, and this is an oval. Okay, these two are triangles. One is an isosceles triangle, looks like an isosceles triangle. The other is a right angle triangle. This is a trapezoid, and this is a diamond. Okay, so like you can create categories, different categories in which you can organize these objects. Okay, so let us do that. Like we have a small, it's not a small, maybe you'll say that the categories have surpassed the actual number of objects. Yes, in the case of a limited number of objects it may seem so, but when you have more and more objects coming into it, so you would be able to adjust those objects into these categories. Now in order to create these categories, we first have the shape category. Okay, we first have the shape category. The base category, or the most general category that we have, is the shape category. Now shape is any combination of a set of points, say a set of points that fulfill a certain criteria. Okay, so you may call that a shape. You may call that a shape. Now that is a very generic definition. Okay, this is a very general definition of shape. If I ask you to draw a shape, okay, you know the definition of shape, and if I ask you to draw a shape, perhaps you will not be able to draw the shape because you won't know what kind of shape should I draw. Okay, you won't know that. So if I ask you to draw a triangle, then you may be able to draw something. If I ask you to draw a right angle triangle, then definitely you will be able to draw something. But if I simply ask you to draw a shape, you may not be able to draw it. Like you would ask what kind of shape. Okay, but shape, nevertheless, like these are all shapes. These are all shapes. Okay, so shape is basically a set of points. Okay, any set of points that give you the perception of a shape. Okay, that give you the perception of a shape. So this is basically these are all shapes. These are all shapes, and shapes can be drawn. Shapes might have area. Shapes in certain cases might have volume. For example, if it is a three-dimensional shape, it will have volume. If it is a two-dimensional shape, it will not have any volume. It will just have some area. Similarly, a three-dimensional shape might have area, but that area would be the total surface area, because it is not just one surface, then it has plenty of surfaces. So when you say the area for three-dimensional shape, so then by that area we would mean the surface area. Okay, so the point that I want to make is that if I give you these objects, if somebody sorry, give you these objects and somebody asks you to categorize these objects into different categories, so then you might come up with such organization. Now this is a class hierarchy. Okay, this is a class hierarchy. All these classes or these different types of shapes have been organized into a hierarchy. Okay, have been organized into a hierarchy. At the very top of the hierarchy, you have shapes that are very general. Okay, general. These shapes have very few attributes. These shapes have very few attributes. These are very general. And when you go down that hierarchy, you find out more specific shapes. You find out more specific shapes. So on the top you have general shapes. Okay, something that is very general. General things are those which have fewer attributes, and those attributes are common among all objects. Okay, so for example, a 2D shape, it is a two-dimensional shape. It is only spread across the x and y axis. Say for example, it does not have any value for the z axis, no z dimension here. So all these objects, whether it is a right angle triangle, whether it is a circle, whether it is a trapezoid, all these shapes, they fit into this category. So 2D shape is a very general category. Okay, a circle is a 2D shape. The relationship between circle and 2D shape is a relationship. A circle is an oval. Okay, an oval is a 2D shape. A 2D shape is a shape. So these objects, if you go up the hierarchy, they have an is-a relationship. A cube is a 3D shape. A cylinder is a 3D shape. Okay, a sphere is a 3D shape. There is an is-a relationship between a sphere and a 3D shape. A sphere is a more specific case of a 3D shape. A right angle triangle is a triangle, is a 2D shape, is a shape. Okay, so there is an is-a relationship between these classes when you go up the hierarchy. A right angle triangle is a very specific form of a triangle. One of its angle is of 90 degrees. It measures 90 degrees. An isosceles triangle is a specific triangle. Okay, it isn't just any triangle. It is a very specific triangle. It has two sides of this triangle have equal length, for example. So this is an isosceles triangle. Now a square is a specific quadrilateral. It is not just any quadrilateral. Okay, it is a specific quadrilateral. It has all its four sides equal to each other, and all its four angles right angles. Okay, so a square is a specific quadrilateral. A quadrilateral is a specific 2D shape. A 2D shape is a specific shape. Okay, so there is a relationship between these classes. Okay, so when you go upwards, up in the hierarchy, so there is generalization. Okay, quadrilateral is more general than these shapes. 2D shape is more general than quadrilateral, oval, and triangle. And shape is more general than 2D and 3D shapes. Okay, so when you go up the hierarchy, you have generalization. When you go down the hierarchy, you have specification. So your classes become more specific. This is how you create class hierarchies. This is a class hierarchy. Okay, all these classes, they are related to each other. This class shape, okay, is a more general form of these two classes. It has the common characteristics of these two classes. 2D shape and 3D shape are more specific types of shapes. They have all the characteristics and behavior of shape, and they have some of their own characteristics and behavior. Now these classes, quadrilateral, oval, triangle, these are all 2D shapes. Okay, they are all 2D shapes. They are more specific types of 2D shape. And the 2D shape is a more general type, is a more general form of these shapes. Okay, so we don't say 2D shape is a quadrilateral. That is not true. Okay, so we only say quadrilateral is a 2D shape. Okay, so this relationship is unidirectional. It is not bidirectional. Is a relationship is unidirectional. It goes only through one way, not two ways. It is not a two-way relationship. Okay, an oval is a 2D shape. A 2D shape is not oval. Okay, it is not always oval. So this statement is not correct. Now, say for example, now some people may differ with this categorization, but if we or let us go, this one is a little triangle. This one's a little less vague. So an isosceles triangle is a triangle. An isosceles triangle is a triangle. A triangle may not always be an isosceles triangle. A triangle may not always be an isosceles triangle. An isosceles triangle is a specific form of a triangle. Okay, but a triangle has many other forms. So we cannot say that a triangle is an isosceles triangle. The point that I want to make here is that this relationship is unidirectional. Okay, so the more specific type, that is an instance of the more general type. So you can say that the more specific type is an instance of the more general type, but you cannot say it vice versa. You cannot say that the more general type is an instance of the more specific type. That is not true. Okay, so the more specific type, it may have additional attributes, it may have additional behavior which will not be available in the more general type. Okay, so this may be more clear in the coming examples that we'll talk about. So let us look at another example. Say for example, I give you different people in an organization, and I ask you to organize those people into different categories. Okay, so say for example, consider our university. So we have students in our university, not as young as this one, but we have students in our university. We have teachers in our university. We have different types of employees, say security guards. We have clerical staff. We have other types of people as well. For example, we have TAs or teaching assistants. So teaching assistants, they are students, but they also get paid. So they are some sort of employees as well. Not exactly full-time employees, but they get paid by the university. So they are teaching assistants. They are different. They are not just ordinary students. Okay. And then we have different types of students as well. Say for example, we can have undergrad students, we can have graduate students, we can have PhD students, and similarly we can have diploma students. Say for example, in our university, there is a gems and stones development center, so they offer some sort of diploma for people from outside. So those people can come and they attend a diploma course for a certain number of weeks or months, so they can be diploma students. Okay, now these are all different types of students, and these are all different types of people. So what if I ask you to organize them into different types and then construct relationship between those types? Okay, so maybe there is possibility that you can come with such a potential hierarchy for this organization. So say for example, you can go with the more general type person. So this is the most general type. In any organization, there are people working in there. Okay, so there are people, and those people then belong to different categories. Some people can be students, and some people can be employees. Now, some students can be undergrad students, can be graduate students. Graduate students would include both MPhil or MS and PhD students. Now, why do we have different categories? Because there are different requirements. Undergraduate students have different requirements to meet. They study for 4 years at least. Graduate students, they study for at least 2 years. PhD students, they study for at least 3 years, for example. Diploma students, they are different. And then we can have alumnus. So alumnus is a student who has graduated, okay, who has